histogram. And histogram are bar graphs for quantitative data. That means data with numbers, okay, with no gaps in between the bars. And then I will show you guys why in a minute. Height of the bars is the frequency or relative frequency of the value in that class and bin. So then we are talking about a range from what number to what number. So it's a little bit different, okay? And the width of each rectangle is the same. A quick reminder, please make sure you write down the things that's in red because that's the way you're gonna take notes. Okay, example number 1. The number of pay-per-view movies rented in the month of January was recorded for 24 random selected Comcast customers. So those are the numbers, and we are going to use that. And you guys have to tell me what is the population. Please pause so you can work through all the questions, and the answer will be followed. Please double check your answer, and if you have any question, please ask me. The last thing I want to just discuss is we are counting how many movies. So therefore, it's discrete also because we don't have a 1.1 movies or 1.2 movies. So discrete is like the whole numbers. Just a quick reminder. Okay, so now what we're going to do is make a frequency and relative frequency distribution table and histogram. So to make sure we have the movie rentals, and this is the frequency, and the next one is relative frequency. Okay, so now movie rentals, there's movies up here that you can see that's smallest number is 4. So I'm gonna start with 4, and then let's see can we fit all of them in by 1. So it's 4, 4, 5, 6, 7, 8, 9, 10, 11. Perfect. And if you just scroll up and down or make the screen a little bit smaller, you can actually see there's 2 4s, and there's 3 5s, and there's 1 6, and 5 7s, and then 8 7, and 9 you'll have 3, 10 you should have 2, and 1 for 11. And so when you do the relative frequency, you can definitely put it in the calculator. And because they are saying it's 24 movies, and if you want to write down the fraction real quick, that's really just going to be 2 over 24, or 1 over 12, 3 over 24, 1 over 24, 5 over 24, and 7 over 24, 3 over 24, and if you want to reduce it, that's 1/8. Usually we prefer you do, and that's 1/12, and that's going to be 1/8. 2 over 24, that's going to be 1 over 12, and you have 1 over 24. Okay, and when you figure out the decimal by punching the calculator, that's going to be about 0.083, and second one is 0.125, 0.042, 0.208, and 0.292, 0.1125, and then 0.083, 0.0442. Okay, so now going the next thing. Well, if we're gonna try to draw a histogram, there's a couple things we have to keep in mind. This is the general rules for making a histogram. 1. X-axis labeled with the variable being used. 2. Y-axis label frequency. 3. Number of bins or bars should be between 5 to 15, and I will show you that in a minute. What does it mean by bins or bars? Number 4, find the range of the data, highest to the lowest. So in this case, the highest is going to be 11. The lowest will be 4 movie rentals. So the general rules for making a histogram. 1. X-axis labeled with the variable being used. 2. Y-axis labeled frequency. 3. Number of bins, bars, should be between 5 to 15. That could be vary, depends how big of a range of data we're going to have. Number 4, find the range of data, highest number minus the lowest number. Divide the range by the number of bins you want. Round your answer if needed. This is the bin width. Number 5, start numbering graph using the smallest number in your data set. Find your bin boundaries by adding the bin width to your lowest number. Okay, so number 1, we are going to label the x-axis, and the x-axis is going to be the movie rentals. 2, label frequency. 3, number the bin, should be between 5 to 15. Because our data set is kind of small, we are going to see, can we get away with 4? We'll see, okay? Then, how to find the bin? Find the range of the data, highest minus the lowest. Okay, so if you remember, the highest number right here is going to be 11. The lowest is 4. So we are going to do 11 minus 4, and that's going to be 7. Okay, that's the gap between the highest to the lowest. Divide the range, which is 7, by the number of bins you want. Now, because the number set is so small, it makes it very hard to have lots of bins. So we're going to go with 4 bins. Okay, pick a number that's convenient for you. Don't do something with a decimal in it. Usually try to stay within a whole number. That will make your life easier. So I'm going to divide by 4 bins, okay? So if I do 7 divided by 4 bins, that's going to give me 1.75. I do not want to have a bin size that is with a decimal. So I'm going to round it up with the bin width to 2, okay? So every single bar width is going to be 2. Now, they say the next one, start numbering the graph using the smallest number in your data set. The smallest number in our data set is 4. So I'm going to start with 4, and I'm going to go up by 2. So that's going to be 6, 8, 10, and 12. That's how I'm going to label my bin size, because my bin size is right here, going up by 2. Now my frequency is on the side. Now if you look at the frequency, the biggest number on the frequency is 7. So I'm going to go with 0 to 8. And then I'm going to take the frequency and say, okay, this is the highest point, that's going to give me 8. Halfway is going to give me 4. And then the other halfway is going to give me 6. And this is going to go 2. Now, you can do all kind of tick mark. I find it so messy, so I don't like to do that. Okay, now we are going to put down the different frequency that happen in that bin. All right, so in this case, you are going to put between 4 and 6. So between 4 and 6, that's group. So there's 5 movies in there. So there's 5 movies. Then 6 and 7, 6 to 8, which is going to be this gap. That is going to be 6 movies. Did you notice? We don't have gaps in between. It's between 6 to 8 movies, not more than 8 movies. Okay, at 8. Now 8 and 9, I think we miscalculated. So we're gonna have 7, so it's 10. We need to add a little bit more. So this is 10. And then you have the next one, which is between 10 to 11. Okay, that's 3. That is how is histogram being done. So I hope you guys understand that we don't just have a number on the bottom. We have a range. And that range between 4 and 6 right here, this is called a bin. Okay, that's called a bin. Now, because that is a bin, we call it the bin size. And then another word for bin is called a class. So this is also called the bin, lower bin limit. And then in this case, if you're looking at the very first one, this guy, the lower class limit or lower bin limit is 4, smallest possible value within that class. And in this case, again, that's the same thing as bin. Okay, the lower class limits is the 4 or the 6 or the 8 or the 10, depends which bin you are talking about. The upper class limit is the large possible value within that class. So in this case, because we are looking at 4 to 6, 6 will be the class with the highest first bar or first bin. For the second bin, the lowest class is 6. The highest class is 8. For the third bin, the lowest bin size is 8. The highest bin size is 10. Hope that makes sense now. So the definition of class width is the difference between the lower, right next to each other, successive, lower or upper class limit. This will also be the width, sorry, there's a typo, of the bars in the histogram. The very first bin or very first class is just 6 minus 4 equals 2. So your bin width is 2, or your bin class width is 2. Okay, going on to example number 2. The following data represent the record high temperature in degrees Fahrenheit for each of the 50 states. And those are the numbers. Now you can see it's a lot of different numbers. So let's answer the question. I'm gonna pause and then please try the problems and the answer will be followed. Okay? We will skip making a histogram using TI-84 for now. I would like to show it to you in class when we do the homework. Moving on, summary of which graph to use based on type of data and number of variables. So first part is the qualitative. And when you have qualitative data, you will have one variable. You can use a bar graph or you can use a pie chart. And if you have 2 variables, you are going to use side-by-side bar graphs. Now the next thing is that's qualitative, that means category. Okay, the next one is quantitative, QUAN. And then if you have one variable, and that's a histogram. And if you have 2 variables, you are going to use scatter plot. And we're going to talk about that in the future. So we already talked about bar graph, and we talk about pie chart. Side-by-side graph, we will see about that. We definitely talked about histogram, and we in the future will talk about scatter plot. Okay, so now moving on, the couple things we also want to talk about is what graph would you be most appropriate to summarize data for each following. Now read through the question. Of an emergency room documents the reason for the emergency room visit, broken bones, etc. Okay, now think about it. Which one is the category? Which one is the quantitative? Qualitative or quantitative? So in this case, the first one is going to be something that we talk about. The emergency room documents the reason for the visit. So therefore, broken bone, high fever. So it's qualitative. So it's going to be one variable because it's only reasons for emergency room. We are trying to find out what is going on at the emergency room. So in this case, it's going to be one qualitative. And we are going to use the bar graph. We don't want to use pie graph. We could, but pie graph usually is harder to do. The next one, read this. A hospital randomly looks at files of patients who have had a day overnight and records the number of days in the hospital for each patient. How many we are staying overnight, number of days. Okay, so that is going to be one, only one, how many days they are staying. This is one variable, and that is going to be quantitative, and that is going to be a histogram because that's the number, that's the bin size on the bottom. You stay 1, 2, 3, 3 days, maybe that's one bin. 3 to 6, that's a bin. That is what the bin is for numbers. Okay, so in that case, we are going to put down histogram. If you have talking about a set of numbers that happen how many times, you use the histogram because there's a range that you can put it in. If you are talking about different kind of category, broken bones, high fever, scrape yourself, things like that, then those are how many those symptoms that happens, categories, and therefore how many times does that happen. Okay, those are the bar graphs that we're talking about. All right, so now going on. So next thing we're going to talk about is identify the shape of distribution. And the point of this chapter is not just to be able to make a frequency table or graph the data. We want to also talk about what kind of shape of this data is when you graph it, what is the shape of that graph? So number one of the characteristics we will be interested in is the shape of the distribution. 2, drawing inferences using the results of a set of simple data. 3, use histogram to look at 3 things: the shape, the center, and the spread. The shape, we are going to talk about a bell shape, a uniform. Is it right skewed or is it going to be the left skewed? Where's the center located? That's number 2. Is it right? Is it really in the middle? C, spread. Spread is kind of hard to tell right now because that takes a little bit more other skills. So we will talk about that in the later on. But right now we are talking about the shape and probably a little bit more. The center is a calculation. We will talk about the center. There's a whole bunch of different ways to calculate center. So right now we are really talking about just the shape. Okay, the shape involves a word called symmetry. Now symmetry means histogram is to be symmetrical. That's when you can fold it vertically in half and get mirror image left to right. Okay, that's kind of iffy because data is not going to be always come out left to right, but we're talking about roughly. Graphing sample data, histogram would never be perfectly symmetrical, but kind of roughly looking. When asked if the distribution is symmetrical, we are being asked if it's roughly symmetrical. And I'll show you guys in a minute. Okay? All right. 4 common distribution shape right here: bell shape, uniform, right skew, left skew. Okay. So this one we are going to say the bell shape because it looks like a bell. That's a bell shape. And then we also said they are kind of symmetrical. Yeah, I know they look like evenly. Not always is going to come out evenly. This is symmetrical, okay? Because if you fold it in half, it's kind of image. They are the same. If you fold it in half, they are almost right on top of each other. Actually, they are right on top of each other for this one. The next one is kind of strange. You probably have never seen it. oh, data is all the same pieces, and that's called uniform, and that's also symmetrical. Well, why? Because if you fold it right in the middle, they all match up. Okay, so the next one is picture number 3, right skew. The reason it is a right skew is because think about the tail. Where's the tail? The skinny side. That is what we're talking about, the skew part. So this is because it's on the right hand side. It's going to be right skew, and it's definitely not symmetrical, because if you try to fold them in the middle, they are not going to come out one on top the other. That's not symmetrical. So if that one is a right skew, what do you guys think this one is going to be? Well, since the tail side of it is on the left hand side, it's going to be a left skewed, and it's definitely not symmetrical. Okay, so thank you so much for watching. That's notes for 3.4 histogram.